Okay, so I've just loaded up a first-person template project here, and this is going to be the first part of a tutorial series where I plan on basically explaining everything that I know in C++. This first one, because it's probably one of the most important things, it's going to be really simple, is the input system in Unreal. So, in the template, this is one I would recommend if you're starting out anyway, because it's pretty nice, has all the stuff you need. So you have your projectile class, your HUD class, your game mode, your character. So the input is done in the character. So if we go into him, you've got all this stuff. You can press hold Control K, then Control O, and that'll snap you between each class, which is a really handy shortcut. So you've got all this stuff. What I actually like to do at the beginning, just on a side note, is literally delete everything about VR and touch because they bloat out your CPP and it gets really annoying, honestly. So if we just turn all this off, that's a good start. Right, so there's that. A bit more organised. Then we just need to fix this up, so okay. Yep, that's good. This. It doesn't take too long, but it's actually worth it unless you plan on using VR or touch. I'll probably isolate these into their own little classes as well because it just makes it too big. Anyway, that should be pretty much everything, right? And this stuff. All this. Don't need any of that. Okay, now it looks good. Now let's just test that still works. Man, compiling is the real struggle. It takes so long. By default, the engine, the engine uses an include called engine minimal, which is the the smaller half of the Unreal Engine for like what you have access to in the code. You can change it to just engine, and that'll give you the whole engine apart from like specific things you need to include. But then again, that makes the compile time a bit faster. So my tendency is to just include what you need and when, as of and when. I suppose while we're talking about that, we can talk about forward declaration as well, because I'm pretty sure you're supposed to include in the CPP. So you include it in the CPP, say your class, and then if you want to reference that class, to like cache a reference to it through some method of some sort, you'd put your reference in the header, but the header doesn't know that class exists because you're including it in CPP, hence forward declaration. So there was an example in here. So within some of these includes, you've got this basically, the input component, and in here it's forward declared. You can either do it here at the top, so the whole file knows about it, by using class in front of the class name. You can forward declare it. So, and this is the using it more specifically. This class now is aware of the input component, so it won't throw compile errors at you when you try and compile, when you use it here, because you could get rid of this class here, get rid of all this, and put the class there as well. That would work. And then if we go to this, you've got it here again. This one's actually not necessary, but it's in the template, so you can do it if you want, because you've already forward declared it in the header. Actually no, this is necessary if you don't include it up here, I guess, but I'm not actually sure 100% where this class comes from, so yeah, when you're doing your own classes you can be a bit more true to how you use this. Anyway, it just means that you tell it that it exists, trust me, sort of thing, right? So all this can work. This check pointer is a validity type assert thing. So basically, it will break point on this line if for some reason this input became invalid or null, which it really should never become. But that's like, this doesn't get compiled into a package. It's more just for debugging and creating the game so you can catch bugs preemptively rather than reactively. Right, anyway, actual input stuff. So here, as you may have read by now, is the actual input. Most of it's, literally all of the input's done in this, which, mind you, only gets run once. So on start, hence setup. So it's not running all the time, because I tried to do something a few days ago which was on the assumption that it was running like all the time, so figured that one out. That's kind of lame, but I understand why they've done it. So it's just, all this is pretty much it. So if you want to make your new one, you type in player input component, and you have actions and axes, right? So let's call it my action, and then you've got, you can either choose pressed or released. There is some more, but these are the two main ones. You need a reference to the U class, which is the class where you're calling this delegate function from. So 9 times out of 10 you'll always be doing it from here, but you can call functions through the input on a different class by having cache reference to the other class and making sure the other function's a U function, which I'll get into in a minute, and what else is there? Yeah, that's pretty much it. You just need access to the other class. So a character is something this class inherits, which is why you can still do that. So jump and stop jump are still built in. A lot of times actually I just make my own jump and stop jump functions just so you can add extra functionality in there. Anyway, so what you do is you type in the class name, so I've called this tutorials, and then it prefixes it with, or after, puts character on the end. See, it's just Unreal's framework sort of auto-generate naming convention. So you call your project something, and then all the default template classes will prefix what they are with your project name. Yeah. So here you can, I guess we need to make a function as a test. So you might as well briefly go over this. Public, that's literally can be accessed anywhere. Protected, that's private unless you're a child of this class, and private, which is technically this bit. If it's not stated, it's defaulted to private. Private is literally this class only. So we've got, right, so if you want to make a function that this class and all its child classes can use but no others, has to be U function for the delegate to accept it, otherwise it will compile wrong and just moan. Void, because we don't want to return anything, and let's just call it test. Right, so now we've got that. Now we can quickly just make a very unorganized declaration of this, or implementation of this function. Right, so there's that. This is a U function. Test input function. So you can make a log. Right. Alternatively to the UE log system, you can do what is it? Engine. I'm not sure. Global engines. Engine. These guys. I think you can use him. Does that give you access to? Yeah. Alternatively, you can debug this way. No. Doesn't exist all of a sudden. I guess you do need the other one as well. I wouldn't recommend doing this here, but just for the purposes of this video. So you can do this for the other ones. I was hoping it would just be in globals, but apparently not. But this one I wouldn't recommend doing here, but just for that one line debug and then you can comment it out, it's fine. It's actually done here. So this is in your tutorials.h, your built-in stuff, and engine minimal is the default, and you can change that to engine to give every class access to everything, pretty much. Keep that minimal though, but only unless you really need everything, which is unlikely, honestly. This is like if you're being lazy and you just want to rapid debug, like, I want to debug that immediately, need to fix this, so you can debug it on the fly like that, or you can do actual debugging, which is probably get into that at some other time. Anyway, this should let me do things now. Oh my god. So you got this function, so actually no. Let's just type it up, and then let's make a ball to register this. So it'll be private because we don't need to use it anywhere else. You can bit field it this way to make a more efficient ball, although it can't be used in blueprints if you do this, which is forcing an int to 1 bit as opposed to like 8 bytes, or 8 bits even, not bytes. And get rid of the blueprint one because that won't let you do it. And it's just Unreal being Unreal. It'll often do this all the time, but there's actually nothing wrong here. It's just the IntelliSense is registering. So here what you can do is comma. This is string formatting. So yeah, just a bit of string formatting. So you can do b input pressed, and then if it's true, output true. If it's false, output false. Right. And this bracket. Yes. So basically, actually, do we have a tick? No. Let's. Oh, do we have a tick? No. Let's go make a tick. This, if you ever use Unity, it's basically update, but if you haven't used Unity, it's literally code that runs every frame, and delta time is the time between frames, so it's the same, well, it will add up to the same on every machine, which is how you create consistency and like smooth behavior by scaling, well, multiplying things by delta time. Anyway, delta time, let's just make the oh my god, my voice. Let's just make the implementation of that real quick. And because you've overridden it, you must call the base class as one, otherwise it will not compile. Well, it shouldn't compile. If it does compile, then I guess something's strange. In my experience, it won't compile if you've overrid without calling the base. Anyway, that's just saying call my base's tick function before you call this one to keep the inheritance chain going. There's a whole controversy on inheritance and stuff, so I won't get into that now, but yeah. Anyway, what we can do, instead of doing this just there, what I like to do is, this variable is how long on screen you want the debug message to stay up for. So if you pass in delta time, it'll be up there all the time, because it's removing and adding it every frame, and because it's literally just displaying information, it's not that costly, so you can do it every frame. If GEngine, you want to do these checks all over the place to make sure you're not using a pointer illegally. So if you hover over this, it says UEngine pointer game engine, and because it's a pointer, so it can be 0, so don't use without checking, as a nice comment notice on it. So if you use this without checking and for some bizarre reason your game engine was invalid, and bam, it would crash. But if you do this, it will just not display. instead of crashing. This over here is called the ternary operator, I believe, ternary, I think. Yeah. Question mark is really confusing at first, but once you understand it, it's really simple. So you have your condition, bool, and that by default is like equals true, right? Because that's how bools work. You can put equals false and stuff. Anyway, question mark, text, true. So if this condition is true, do the first thing, and then separated by the colon. If it's not true, do this. It's really useful for bool linear conditions, so it's a way to compact your lines down into one line, but it's arguably not very readable, so if you're working on a team project you might want to discuss if you should use these, because they can be pretty hard to read. Although if you understand them then they're not too difficult, I don't think. Yeah, I think it's pretty nice way, especially for this. This -1 is like just a invalid int, essentially, a invalid uint, should we say, which basically means it'll put this message in the top left corner all the time, or it will default to that position, and new inputs will automatically go underneath it, so you don't have to worry about the positioning. Right? Okay, so my action, and then basically we want to do this again, but on released. So, there's that. Talked about quite a bit actually, but this is more relevant. Input stuff, press released, test function. If I press whatever I bind this to, it will input this in the message log, and will also set this to true. And I guess we need another one. Make the release function called test released, and where's my test? Here we can do make another one. I'm hoping you're following along. Right, there's that. Then we just need to make this implementation. So it has to be ufunctional again, otherwise bad. This log temp shenanigans is the default log. You can make your own logs, which I might actually do a video on. It's really simple. You can just type in ulogs into Google, and the documentation will give you the whole thing that you can just paste into your tutorials.h. Other than that, this log temp one works fine if you don't want to make your custom logs. Right, so input was released, and then b input pressed equals false. So basically, when you press it, it will set it to true. This will turn to true on this screen, and then while it's pressed it'll be true, but then as soon as you let go of the key, it becomes false, and this one will print. Alright? So notice these will be one-timers. This will print once, this will print once, this will print every frame. That's a key distinction here. Bound events only happen once unless you tell them otherwise, which I'll get into when we do shooting, because there's a whole topic on shooting, which will be a lengthy video. Anyway, input stuff. Now that we've actually done that, there's two ways to actually go about this input stuff. You can go, I've got to find it now, yeah, config, and change the default input.ini. You can do it in there. If I just go in there real quick, you've got all your input stuff here, so you've got actions and axes, so you can add it in here. However, I'm not a fan of this because it feels rather sketchy. I'm not sure, there's nothing wrong with it, honestly. Anyway, what I do, because of habit, is how I first know about it, is you go into project settings, which is located edit, project settings. Alternatively, you can probably find it somewhere along here, settings, yeah, here as well. Input, which is somewhere, here it is, halfway down engine, go in here, open up your axis and your actions. So these are the built-in ones, right, we don't need this reset VR rubbish, we don't need, that's pretty much everything. And then in here, it's an action we've made, so we'll call it, I forgot what I'll call it, my input. Yeah, that'll pop up with you into the ini file, just to make sure I got this correct. And then we'll bind it to, I don't know, 1. So if I press 1, it will do stuff. And the output log is this guy, which I have pretty much every time I'm in play mode because it tells you a bunch of useful information. Wow, that's annoying. Okay, so that looks good to me. axis is slightly different. These take a float parameter by default, which is basically to measure the how much of something you've done. So used for literally movement and aiming stuff. So turn, you have your turn rate, and so if we just snap to one of these functions, it's got a float parameter, and notice how it doesn't need to pass in the float here because it's done in the axis side of things. This is quite important because you can't have parameter functions in these default ones unless you do a really long-winded SERP, which I figured out the other day, but it's really not necessary because you don't need to pass in parameters really, there's always a better way. Anyway, so that's just literally it. You check that it's not 0 or whatever, and do your stuff. Anyway, let's compile this and show you what goes on. It's been quite a lengthy video, but I've been trying to explain every new thing as I'm just typing it in. So focus was mainly input, but there's a few background things you needed to know, and this is the first video, so it's just important to kind of, you know, say everything. Compiling. So yeah, it's really not too complicated, I hope. Key takeaways is you function your functions that are bound. That's important. In the implementation, you can literally do whatever you want in the implementation. And now as a demonstration, so notice in the top left you've got input pressed false. So input pressed false. If I press 1, notice it's gone to true, and if you can even see it, I'm not sure if you can, but at the bottom left it says log temp : warning : test dash input was pressed. So that's the UE log, happens when the function is called, so that's how you can confirm that the function was called, on top of the fact that the debug message went true, and you can let go and it'll go false and it'll say released in the bottom left, and that's pretty much it to input. So I'll quickly implement something that you might actually find useful now. So if we make, this is how I would do sprinting, like really quickly, like not a fancy sprint, just a sprint. So make a U function for sprint begin, U function for sprint end, and then you need a function called sprint, which will be actually applying the sprint, and then we need a bool. So just copy this guy, calling it B is sprinting. Right. Bit field that guy as well. This category is basically where it gets put in the editor. So bool B is sprinting, only visible, not editable, and we're basically going to have sprint begin, which is when left shift to be pressed. So when left shift is pressed, toggle bool to true. When left shift is released, toggle bool to false. Apply changes based on bool. Okay, so that's literally what we're going for here. Okay, so yeah, sprinting. Let's get that going. I should put it here. So you have sprint, which is not a U function because we're not calling it via the bound stuff. Sprint begin, which is going to be this. Going to have tutorials character sprint end, which is the opposite. Alternatively, you could have one function. Well, actually, no, it'd be risky with one function, I think, where you just do B is sprinting is equal to not B is sprinting. But I like this way because it's more reliable. This way is you can either do one of two things. Alternative one way is you can do this standard. If sprinting is true, do this. Alternatively, you can do a switch statement on important just to say this just because you may not be aware of switch statements. This achieves the exact same thing. So you can do, what is it, get character movement max walk speed equals, oh, we're going to need some more variables. We'll call it initial walk speed, and then this is just my convention, how I do it. Otherwise go to sprint speed. So we need two variables basically, sprint speed and initial walk speed. These can be private because we don't need to change these anywhere. So u property edit, okay, edit anywhere because you want your designers to be able to adjust this stuff. Blueprint, read, write is the same deal but in blueprints. Category equals custom, and this meta thing is just so you can, it's basically making it public without making it public, which sometimes you don't want to do if you know you don't need it to be public, but it helps, honestly. Alright, so these are floats. Sprint speed equals, we'll make it 1200, and then make another one called float initial walk speed. It is going to be half of that. Actually, to be honest, it doesn't matter what you're going to do here, because what I'm going to do is on begin play, you can do initial walk speed equals get character movement max walk speed. This is done so if the speed was adjusted on the fly in Blueprint, say, the sprint mechanic will be updated. Basically what I'm going for here is a foolproof system. So if you suddenly thought that, he's so slow, we want to make him faster, you make him faster right in the Blueprint, bam. The problem is that'll ruin your sprint if you've hard coded it this way. So one way to automate it essentially is to do this equals so you can just do it like that. So store initial walk speed. So what is the speed when you start the game? Say 600. Sprint speed. Oh, that's just going to be double that. You could make this public as well, make it like a sprint modifier, as opposed to making these values public. There's literally billions of ways of doing this. This would work, I'm almost certain. And then, yep, that's that. And then we just need nothing else really, that's pretty much it. So, Control K, Control C for fast commenting, and then it's Control K, Control U for uncommenting. So that'll change your sprint based on, I got these wrong way around. If sprinting, go to sprint speed. If not sprinting, go to walk speed. Bam. True. Yep. Right. So we just need to make the functions. So we've already got the functions basically here. So sprint begin, sprint end, and then you call this one sprint. Sprint. Pressed release. That's important. Begin, end in the right order. Perfect. So that'll run. All this sprinting stuff. Oh, and one last thing. In tick, you need to apply the sprint, basically. So you call this sprint function, which is basically a check for sprinting. To be honest, you could probably not have this and put it in these two functions. So you could, instead of this ball, you probably could just bump up the speed here. But this way is a bit more unreliable if you do that, because if you want other factors to influence your sprinting, say if you start aiming down sights, you want to stop your sprinting, you can't do it if you don't do it a way similar to this. So keeping track of your sprinting is good, because then you can use it in the animation, yada yada yada, yada yada yada. Compile this, and we should be good to go, really. Getting there in the end. This is a super long video, but C++ takes forever. So go to the blueprint. This is the default one. Open it up. Open up the full blueprint editor. So this is essentially your prefab if you're familiar with Unity. If not, it's basically a saved object with pre-saved stats, so you can edit all your code in here. So notice initial walk speed 600, sprint speed 200. These balls are just visible only for debugging, and bam. Let's go. So you can change these, but you can't change those, right? So now if we play, it might be hard to notice, but if I sprint, oh, of course it's not working because we forgot one thing. I was getting concerned then. We forgot to actually map our input. So sprint and left shift. So now it will work. You know, just to demonstrate a bit better. Right, that shouldn't take long to compile. So now, once I start sprinting, you will see the acceleration taking place, and then the character would move up to the new max walk speed over time, based on its acceleration in the character movement component, and the variable will toggle. So, sprint true, sprint false, sprint true, sprint false, sprint true, false. Yeah, pretty easy, I think. Alright, so that's probably going to wrap it up for this one. And yeah, let me know if this is helpful or not. If it was too long or not. Would you rather me just show you implementation or implement it on the run? I'm not sure which is better, but I think it's good because it shows you my process, at least. Right, that's it. Until next video.